Hello students. Today I am going to discuss another problem on fluid mechanics and the simple harmonic motion. That means here it will have both the concepts, concept of buoyancy force and the concept of simple harmonic motion, time period of oscillations. Uh, the question says, consider a solid cylinder of the density rho s. Uh, the density of the cylinder is given as rho s. Cross sectional area is given as A, and height of h. Floating in a liquid of density rho l. This is your height. According to the equation, this will be your diagram. The density of the liquid is rho l. Density of the liquid is your rho l, as shown in the, and also it is given as rho l is greater than rho s. Okay, means density of liquid is greater than the density of the cylinder. Okay, if it is depressed slightly and released, then find the time period of its oscillations. So let's proceed. Now, the previously the cylinder is in equilibrium, right? Before depressing, it is in equilibrium. So we can write weight of the cylinder is equal to buoyancy force, right? Is equal to buoyancy force. Now what will the weight of this? Weight is your mass of the cylinder into g. Okay, is equal to buoyancy force is your volume of the submerged portion of the body, then density of the liquid, and into g. Okay, so this is your buoyancy force. Now we can write mass of this cylinder as A into h into density of the cylinder rho s into g. Okay, density into volume will give you the mass, then rho l, we don't know this volume of the body submerged, we'll write it as A h dash, where h dash is the submerged portion of the body. Okay, submerged portion, or you can say submerged height. Okay, from this we will get h dash as the submerged volume, h dash as rho s by rho l into h, right? Where this h dash is your submerged portion, as I have already written here. H dash is submerged portion in equilibrium. Okay, in equilibrium means net force upward and downward is equal. Now, okay, let me take this as equation number 1. Okay, so now if we depress this, cylinder by a certain amount, certain displacement, let me take this as dx. Okay, dx or x you can take. Let me take it as x, but this x is very small. Okay, and if it is released, then it will perform SHM. Then if you depress this by a small amount x vertically, and if you release it, then it will perform SHM or oscillation. It will perform oscillation. Now we need to find out the time period of the oscillation. Now uh, during this, when we depress this by an amount x, then at this particular position, at this position, at this particular position, a position dot কি হবো, we will write the force equation. Okay, we will write the force equation. যেতিয়া আমি x ডিসপ্লেস কৰি দিম তলৰ ফালে, তেতিয়া কি হ'ব, ভলিউম অফ দি সাবমাৰ্জ পোৰ্শন বেছি হৈ যাব, আৰু ভলিউম অফ দ্য সাবমাৰ্জ পোৰ্শন বেছি হৈ যোৱাৰ লগে লগে কি হ'ব, ডিসপ্লেস লিকুইডৰ মাছটো বেছি হৈ যাব, ডিসপ্লেস লিকুইডৰ ভলিউমটো বেছি হ'ব, এণ্ড ডিসপ্লেস লিকুইডৰ ভলিউম বেছি হোৱাৰ লগে লগে ডিসপ্লেস লিকুইডৰ মাছ বেছি হ'ব। মিনছ ইফ উই ডিপ্ৰেছ দি চিলিণ্ডাৰ বাই এন এমাউণ্ট এক্স, দেন দ্য amount of displaced liquid will be more. That means mass of the displaced liquid will be more. That's why the buoyancy force will be more, but it will remain same. So that's why the net force, we can write it towards the, again it net force will be along this direction, means towards the equilibrium position. Okay, this is the equilibrium position. So net force, you can write it as F net as W minus buoyancy force. That means buoyancy force at this point, at the new position. Okay, let me take this as A, at the new position, buoyancy force. Now at this position, what will be the net buoyancy force? Buoyancy force after depressing, depress, is equal to how much? It will be equal to A rho L A into H dash plus X, because now the height of the submerged portion of the cylinder will become H dash plus X into G. Okay, now this will be your buoyancy force at this position when we depress it by an amount X. Rho L, what is the value of H dash from equation number 1? That is equal to rho S by rho L into H plus X into A into G. Okay, so this will give us rho L X A G plus, this will got cancelled for first term, we'll get it as rho S H A G. Let me take this as equation number 2, and if we put this for the net force, in this equation, we will get F net as W. What is the weight of this cylinder? Weight of the cylinder is density of the cylinder, volume of the cylinder is A into H, total height of the cylinder, into G, minus buoyancy force is your rho L X A into Z minus rho S H A into G. Right, now this and this term will got cancelled. So F net, we can write it as minus of rho L A G X. Okay, let me take this as equation number 3. এতিয়া আমি যদি চাও কি হবো, this F net is on the cylinder, right, on the cylinder. If we write the force equation, then we can have mass of the cylinder into acceleration of the cylinder, okay, is equal to minus of rho L A G X. So this will be the force equation. Now what we can write for the mass of the cylinder as rho, density of the cylinder, and volume of the cylinder is A into H, this is acceleration of the cylinder, is equal to rho L A G X. Okay, now this rho S A got cancelled out. Okay, A got cancelled out, then we are left with AS is equal to minus of rho L by rho s into h, rho l into a g into x. Okay, this is equal to minus of rho l g by rho s into h x. Now you see this will take the form of as is equal to minus of omega square x. Okay, minus of omega square x. That means we can have d2 x by dt2 plus omega square x equal to 0, which is the differential form of the SHM. Okay, differential equation for the SHM. Okay, okay, so comparing this with this equation, we will have the omega s root over rho l g by rho s into h. Okay, so this is the frequency of oscillation. Now what is the time period? As you all know that omega is equal to 2 pi by t. From this t equal to 2 pi by omega, so from this we will have the time period as 2 pi omega is your rho s into h by rho lg. It will be like this, is it? So this is your time period of oscillation and this is the frequency of oscillation. I hope all of you have understood this problem. Thank you.